What if you want to compare two samples and two populations? For example, if one river is more contaminated than the other, if one medicine works better than the other, and all that kind of things. You remember we have learned from confidence intervals that we cannot use statistics calculated for individual samples to make this kind of inference. We need to take into account the difference of these statistics, right? So that's what a two-sample t-test does, actually. The idea is very similar. You already know how to extrapolate one sample t-test to the case of two samples. We just use t-distribution for the difference of two means instead of for every separate mean. And we are going to use the same distribution here, and we will use the same intuition like we did it for the one sample t-test. So first of all, you remember that's how we calculate confidence interval for the difference of mean, right? So this is the difference we expect to see in population. We don't know it, so we can calculate it as an interval estimate. We just take a difference of our sample. We take a t-value which depends on the confidence level and degrees of freedom, right? And then we take the pooled standard deviation of the two samples, or like standard error of the difference of means, right? There are different cases, for example, different sample size, same sample size, and then what will be the variance, different or not for the population. In our case, for example, for rivers, the variance seems to be the same. They're pretty close to each other. So we can use this simple formula to calculate this pooled standard deviation or standard error for the difference of mean. Okay. Now we are going to use the same idea. So in the case of confidence intervals, we know all these things, right? And we don't know this one. But if we make a test, we know the difference of means. That's our null hypothesis, right? For example, we believe that the populations are the same, so the average of populations is the same. It means that the difference of means will be 0, okay? Or we believe that one population has larger average than the other population. In this case, the difference of average will be above 0. So we know or assume the true difference of the population, and we know statistics of our sample. Therefore, we need to estimate one thing: how far the difference of means for our sample is from the null hypothesis, from a difference of means of the population we assume about. Okay, then it's the same. It's a t-score. So we standardize this difference. We take a difference between the null hypothesis and the sample difference, and then we divide it to the standard error of the difference, right? So that's our t-value, and then we can use again the standardized t-distribution and either both tails, one tail or left tail or right tail, to find out how extreme this t-value is for given sample size and for given difference between the null hypothesis and the sample statistics, right? And then if sample size, if two samples have the same amount of values, and we assume that standard deviation of the populations are the same, we can use this simple formula for estimating the standard error of the difference. Okay. Now that's it. And t-value tells you how far the difference of the sample means is from the assuming difference of the population means in standard errors. For example, 2 standard errors larger or 3 standard errors smaller, and so on. Okay. Now let me give you an intuition about different cases. Okay, and what the meaning of this t-value if we are talking about difference of means and difference of population. Okay. So let's assume the 3 cases. What will be the difference about in these 3 cases? You can see that we have 2 populations, red and blue, and then we have a deviation. This is a distribution of average values for the population, right? So we have this distribution, we have this distribution, we have this distribution. Okay. So if you look at the difference between the peaks, between the true average values, the difference is the same in all 3 cases. But then the standard error getting larger, larger, larger. For example, because the standard deviation is larger, or sample size is smaller, right? So the larger standard error is, the less clear we see the difference. Okay, so the t-score, it tells you this ratio between the difference between groups and the variability of the groups. Okay, so that's the meaning of this score. It tells you how clear the difference is. If t-score is large, then the difference is clear. Of course, it depends on the null hypothesis. And if t-score is small, then you don't clearly see this difference. So it means that you can't reject null hypothesis. Okay. So you can think about this as a signal and noise ratio. Okay, imagine that you are listening to a music in a big auditorium. And if this auditorium is full of people and they are talking to each other, you will probably not hear the music if you don't use the headphones, right? But if you are alone in this auditorium, then you will clearly see this music. So the music is signal, and then what people are talking or in the level of the noise in the auditorium, it's actually noise, right? So this T value, it's a ratio between signal and noise, the clear difference and the variation of the in the population, in the groups. Okay, and then we can just compare how we do a t-test for 1 and for 2 samples, and then you will see that they are pretty much similar. Which just the difference only in 1 sample we use average value, in 2 sample we use difference of average values, right? So in 1 sample case, this is how to calculate confidence interval for the population average. This is how to get a t-score, which tells you how big the difference is between the sample mean and the population mean. And then this is how to get the standard error for the given degrees of freedom, right? So that's the formula for calculating the t-score. Okay. For the 2 sample case, we have the same idea. So we use t-distribution for sampling distribution of average difference of average values for our samples, and then we can calculate the t-value that tells us how big, how far the difference of our sample means is from the difference of the population means in standard error. Then if your sample size is the same, and we assume that the variation, the standard deviation of the populations are always the same, we can use just simple formula for the calculation of the standard error of the difference, and that's the t-value, right? We can actually simplify this by thinking of what kind of null hypothesis we may have when we have a 2 sample case. Well, you think we have actually 3 possibilities. We either assume that the population average are equal, it means no difference between the populations. Alternative hypothesis in this case will be that they are not equal, right? Not equal. μ1 and not equal to μ2. Or we assume that one population has larger average than the other population. The alternative hypothesis will be like this. Okay, and then we assume that the average of the first population is smaller or equal to the average of the second population. So the alternative hypothesis. Now look, in all these cases, we can just compare the differences with 0, right? It's either equal to 0, above or below 0, above or equal to 0, or below or equal. So we always compare the average of we always compare difference of sample means with 0, in fact, right? So now we can simplify it, so we can get rid of this one because it's always 0, we compare it with 0, and that's the t-score. Okay, so we just take the difference of our means of the samples and divide to standard error for the difference. So it will tell us how far the difference is from null hypothesis, assuming that, for example, we don't see any difference between the populations. Now how to calculate a p-value. When we calculate a t-value, we can also calculate a p-value that gives us a probability, a measure of extremeness of our 2 samples, a probability to get samples as extreme as ours, or even more extreme, assuming that null hypothesis is true. Well, it depends on null hypothesis. If null hypothesis is equality, so it means that there is no difference between the populations, then both cases where you have a big positive difference and big negative difference in your samples will be extreme, right? So both directions will be extreme. So in this case, the p-value will be a sum of these areas on the left and on the right part of the t-values, negative and positive t-values. Well, if you assume that first population has a smaller average value than the second population, it means that the difference should be negative, right? Or at least should not exceed 0. But for sample, of course, sometimes it can exceed 0, especially if sample size is small. But the more larger, the more positive your t-value is, the more extreme the sample becomes, right? For being negative, actually, if population average is negative. So it means that you will need to use the right tail in this case. So the more positive t-value is, the more extreme your samples are relative to the null hypothesis. And then finally, if you have this null hypothesis, assuming that the difference is positive, so it means that this is the direction of the extremeness, right? So if your sample average, difference of your sample average is negative, then it becomes a bit extreme, and the bigger difference is, the more extreme it becomes. So the more negative t-value is, the bigger, the more negative t-value is, the smaller p-value will be. So in this case, we use a left. In this case, we use a left.